Hello everyone, what's up? Welcome to Mammoth Interactive's Introduction to Coding in Unity and in C#. In this course we're going to learn how to use the most basic concepts and subjects in coding. So we're going to learn how to use variables, we're going to learn what are methods and what are they for. We're going to work with conditional blocks and also with loops and other things that they appear while we are developing a game. This happens pretty much naturally. And even though what we're going to see is very simple and there's just 1 hour of videos, it's very important that we understand these things just right because we use them all the time. Every line that we write of code, uses these basic concepts. So it's important to understand this very well so you can later develop your games the right way and, well, make them be a hit in the App Store or the Google Play Store, for example. My name is Glauco Pires and I've been working in the game industry since 2010, and throughout all of these years I've worked with several different game engines and developed dozens of games. So I've worked with Unity, with Unreal Engine, I make HTML5 games in Phaser, for example. I've made games in Construct, also I've made Flash games, so I have a lot of experience that I collected during all this time, and I want to share this experience with you by, well, pretty much telling you only the most important parts so we can make this game quick and also make it easy, so we can understand it the easy way. So to start this, you of course need to download Unity. If you don't have that already, you can just go to the Unity webpage, unity3d.com, and download Unity. And, well, pretty much that's it. In the next video, we're going to learn how to work with variables. I hope you're excited to start this, and I'll see you soon. Hey there, welcome back. So in order for us to learn more about coding in Unity and in C# in general, we have to make a very simple project. So we open Unity, go to the top right corner of this window and click on New to start a new project. This project name is going to be Code Introduction, and the location is going to be a projects folder. We're going to leave 3D as enabled, and we're just going to click on Create Project and wait for Unity to open. So we're going to take a look on some very basic concepts here, but before we jump into coding, it is interesting to have a game object in this scene, because the purpose here is to test different concepts like variables. We're going to deal with methods, we're going to use loops, and then we're going to change how something is being rendered in the game. So we have a blank project, we have a main camera and a directional light as usual, and what we want to do is to start by adding a cube. So we go to our hierarchy window, we're going to right click, select 3D object and then cube. When we do this, we have a default cube in this scene. We can set its position to be 0, 0, 0, so it's centered in our scene. And to change its color, just so it contrasts better with this game, we're going to go to our assets folder, we right click, select create and then material, and this is going to be named cube material. For this cube, we want to select an orange color, so we go here to the details of the material and we're going to select orange. Now we drag and drop this material here so it's applied to the cube, and right now if we press the play button, we have to wait for Unity to, well, basically process the scene, and we can have a better view of this cube. And to make the camera to be closer to the cube, we can just select the main camera here and change its Z position to -4, for example. And just so we don't lose any work that we do here, let's save this empty scene, or this basic scene here. We go to File, we hit Save Scene, and after that we're going to save this as game.unity. So how scripting work in Unity? Notice that every game object that we have in this hierarchy, as we see in many other lessons, and, well, if you have used Unity for 5 minutes, you're going to notice this, we have a list of components for every of these game objects. And the way scripting works in general in Unity is you create a script file, it could be written in C# or JavaScript, for example, and you attach this script to a game object. More precisely, you're going to add a script as a component for the game object, and that allows you that allows you to basically write any custom behavior that you want. Okay, so Unity provides us with things like physical collisions, we can have materials, we have some 3D primitives, but if we want to do anything that's a tiny bit more complex than what we have in Unity, and well, we're going to need to do this if we want to make some fun games, we need to go to scripting. So we're going to start by making a script for this cube. We're going to our project window, we're going to right click, select create, and we're going to choose C# script. A new file is going to appear in the assets folder, and we're going to rename this as cube. Okay, now we hit the enter button, okay, the enter key. Let's wait for the compilation to complete, and notice that every script file that you add is going to trigger a little spinning wheel in here. That's basically to tell you that the compilation is happening. Okay, it's a process that is going to get all the lines that you write in your code, and it's going to convert to a format that is better for your game to process. Okay, this happens every time you change even a character in your code. Okay, it needs to recompile the project to see if everything is going well. If something goes wrong with your code, then you're going to have to use the console window. Okay, if that is not enabled here, you can just go to Window and press the console button. So the console window is going to show you details, and better yet, it's going to show you messages regarding your project. So if you make any mistakes in your code, so if you forget a character, if you used an invalid variable name, for example, you're going to see some messages with a red sign in here, red icon like this one. Okay, to tell you that something's wrong. It's going to give you a hint of what's wrong, and well, it's up to you to fix the code. If there is something that could be better written, okay, if there is a way to optimize the code, or maybe there is something that you created but is not being used, you're going to see a warning, which is going to be a message with this yellow exclamation point here, exclamation mark. Okay, so it's just something that is not going to stop it's not going to make the game stop working, but still it's something to keep in mind. And you can also add some simple log messages, some well, informational messages. For example, if we're testing our game and we want to see the value that is stored in a variable, we can just print its value in the console. Okay, so you can well see how it's going. This is very useful for debugging your code to see if everything is running properly. Okay, so now that you created this script, notice that you may try to open the script and try to write some lines in here, but right now this script is not going to be executed because it's attached to nothing. Okay, so we made a script file, but we need to attach it to something. To perform that attachment, we can just select this cube script, drag and drop here to the cube game object, and you notice that there's this cube script file in here. Okay, there's a little component that has been added to the cube game object. Or if you have the cube selected and you have the inspector open here, you can just drag and drop the script here. Okay, so now for this cube we have a fourth component. Okay, we have transform, mesh filter, box collider, mesh render, and now we have this cube script. So let's start coding. We're going to double click this cube file, and once you do this, you notice that MonoDevelop is going to open. This software is great for coding. Okay, it's a coding interface, it's free, it's open source, it already comes with Unity, so if you didn't change any of the default settings, it's going to be installed. But if you want to use any other tools, if you want to use Visual Studio or Sublime Text, Notepad++, whatever you think is good for you, if you're used to it, then you can just configure Unity to use this text editor by default. Okay, you're not it's not well, it's up to you to choose whatever you want. Okay, and now that this software opened, we have a few lines written in here. Okay, it's not an empty file, so we need to understand what's being written here. Okay, and to start, I'm going to delete these lines here. Okay, so let's start with just this. Okay, these first two lines here are basically including namespaces. Okay, and namespaces, imagine like namespaces are folders with several utilitarian files, utilitarian definitions. Okay, so when we say using Unity Engine, it means that the code that we're going to write here is going to use some things that were already implemented in the Unity Engine. And when we say using system.collections also, for example, it means that we are able to use certain parts of the code that were already written in the C# environment for collecting, well, objects together, for example, by using arrays, using lists. You're going to see a little bit about this soon enough. Okay, but essentially, this means that we don't need to reinvent something that's already done for us. Okay, it's very important to keep that in mind. Sometimes we have some pride. We want to create things from the ground up, but to keep things fast and to make us focus in the game instead of writing something that is already done, we have to take a look at what tools we have available for us. So that's why we use these lines. Okay, and this block of code here is basically the definition of the cube class. Okay, so whatever we write between these curly braces is going to be changing how the cube is behaving. Okay, and these curly braces, they are basically defining the scope of this class. Okay, so here we say that we are defining a class called cube. This cube extends monoBehavior, which is the base class for every game object that we're going to use, and whenever it's between these curly braces is going to be, well, the actual definition of the class. It is very important to understand these two characters here because they define the scope. They define what is going to happen once we enter here. Okay, and the first thing that we want to look is variables. Okay, what are variables? What are they for? Variables are basically a way that we can use to store data in the memory. Okay, so you have a running game or a running app, for example, and for instance you want to store the age of the player, or you want to store what time is it right now, you want to store if it's raining or not, you want to store an email. So data can be stored by developing apps. Okay, you can just allocate a position in memory. You can allocate a certain amount of memory to store some data. So for example, for the cube, we may want to create a variable that is going to change the size of the cube. Okay, because right now, if you go to Unity and take a look at the cube, the size of this cube is 1, 1, 1. Okay, you just check the scale property. The size is 1 on X, 1 on Y, and 1 on Z. But maybe we want to modify that scale. So how do we do this? You can go to the cube script in the definition of the class and type here public float size modifier, and we're going to set that to be 2.5f. Okay, so let's take a look on what we've just written here. First of all, we are saying that the variable that we're declaring has a name that is size modifier. Okay, we don't need to memorize a random number like this one. Okay, that would be an address to a certain position in memory that would store this data for us, but we can use whatever name we want. Okay, of course there are some restrictions, there are some reserved words, but in general there are no conflicts here. I'm just declaring a variable called size modifier. Okay, when I type float, it means that I'm saying that size modifier is going to store a floating point number. So it's a number that contains a decimal part. Okay, it's not a whole number like 1, 2, 3. It could be 1.15, 2.3, 3.1415. It could be numbers that contain the decimal part. Okay, a part that is lesser than 1. Okay, when we add this public keyword, it means we are changing the access modifier for this variable. So this means that this variable can be accessed in other places, so other classes can access it, and better yet, this is something that is going to be editable in the Unity editor, and I'm going to show that to you soon enough. Okay, so this declaration could end here. Okay, it could be just size modifier, float, public, and a semicolon to finish this statement. But we can already initialize it. We can start by already storing a value in here. So we use this equal sign. This equal sign is not used for storing, for making comparisons. So for example, you don't want to ask if 1 equals to 1, for example. That's not how you compare things. You're going to see that soon. When we use an equal sign on only 1, it means we're making an assignment. So whatever we put here is going to be stored in this variable, size modifier. Okay, so if we use 2.5f, it means that we're storing 2.5. Okay, the dot basically separates the whole part from the decimal part, and f is just to say that this is a floating point number. It is important to have this character here. And now, if you save this script and go to Unity and wait for this compilation to happen, then if you look at the cube script, you're going to see that now you have the size modifier variable in here. Okay, so it's exposed in the editor. So if you want to change the size modifier, you don't need to go to this script and change the number and then wait for another compilation. That would take a lot of time. It would spend a lot of time. So it's very good that we can change things in here. So while the game is playing, we can change these variables and see how it impacts the game. Okay, that allows you to well, focus more on the game design. Okay, so you want to do something that is fun, you want to do something that's going to make the player to feel nice, for example. And to do that, you need to really test a lot and experiment a lot until you find the values that just feel right. Okay, it's one of the greatest things of having this here. Okay, notice that we used a floating point number size modifier, but let's say we want to store a name, for example. If we want to rename the cube, how do we do this? We can make another variable, so we can type here public string new name equals to, and let's start with an empty string. Okay, so we made a variable called new name. We say that the type of this variable is string. Okay, so it's a collection of characters. And we say that it's public, so it can be accessed in other places, even in the Unity editor. And we start by using this string here. Okay, every string that we make, any text that we want to write, needs to be enclosed by double quotes. Okay, so for example, if we want the name of this cube to be QB, okay, I'm not very creative today, but well, QB, or I don't know, Mark. Anyway, let's use QB. Then this is going to be the string that's going to be used here. Okay, we can type whatever we want. We can use special characters. We can use an exclamation mark. We can use numbers. Okay, we can use well, pretty much write any text that we want in here. Okay, and if we save this and go to Unity and wait for this compilation to complete, we're going to see the string again. Okay, we have a new field. New name, and well, the one that we wrote there is going to be here, but if we want to replace this to something else, like QB42 for example, this is the value that is going to be used. Okay, and now that we did this, let's take a look on one more type of variable. Okay, and this one is very interesting because it's going to be used in other classes. Okay, so we can make a public Boolean variable. Okay, so what is a Boolean variable? This is very interesting when you're programming, because a Boolean variable can have only two values. Okay, numbers can have millions and billions of different values, but Boolean values, they only have two. It's either true or false. Okay, so you say that, well, for example, we can change, let me see if we can change something in this cube. Okay, maybe we can make a variable that is going to say that the cube is going to be rotated or not. Okay, so we can add public bool is rotated and start as false. Okay, so a better way to visualize this is to simply save the script and go back to Unity and see the new field that is going to appear here. Notice that different from the size modifier that is a floating point number and the new name that is a string, is rotated is a checkbox. Okay, because we only have two different possible values. True, so it's checked, or false, it isn't checked. Okay, so it is interesting to see how this works. Okay, and the Unity editor is going to help us a lot with this. Alright, so now that we have these three variables in here, let's say we want to actually make them work. Okay, so what if we want to change the size of the cube to this? What if we want to change the name of this game object to this value here, QB42? And what if you want to make the cube to be rotated? We're going to learn how to do this by the usage of methods. We're going to see this in the next video. Okay, so what are methods? There is an easy way to explain this. Imagine you are watching television, or you're doing, well, pretty much something else, and you want to change the channel. Okay, maybe you're watching a movie and that movie is boring and you want to change to anything else but this channel. So if you want to change the channel, you have to press a few buttons in your remote control to do that change. Okay, so imagine you are on channel 20 and you want to go to channel 42. So to do this, you press the numbers 4, 2, and after a few moments without you giving any input to your remote control, to your television, then the channel is going to be changed. So methods, they work like operations, they work like they are functions. Okay, so you want to change the channel in the television, so you're going to inform that to the television, and you're going to pass parameters. And in this case, change channel receives only one parameter, which is the number of the channel you want to go to. Okay, so that's pretty much how it works. And everything we do in computers require the usage of methods. It requires the use of functions. Okay, it's more or less the same thing. So you need to do operations all the time, and that is even more important in games because they are an abstract experience. Okay, gaming is about fun, it's about action and reaction, it's about for example, you trying to follow a different route, and imagine this route contains a trap, or maybe it contains a different enemy. It is interesting for you to have the practice of playing games so you understand what is happening. Okay, so for instance, you need the key to open a door. So if you get the key and you go close to the door, then you can imagine, oh, okay, so this time the developers, they say that if I get close to the door and I have the red key, then it's going to call a method that is going to open the door. So it's healthy to start thinking things like that. Okay, so let's start using methods in here. Right now we just have a few variables. Okay, we have size modifier, new name, and is rotated. So what do we need to do to start using these? Okay, there are two very interesting methods that already come with any script that we create here in Unity. Remember, we deleted them before. Okay, so we have a method called start. Okay, so let's start declaring it back here, and this is used for initialization. Okay, so what did I do here? First of all, this is the method declaration. Okay, the method name is start. We say that it's void, so it doesn't return anything. It contains no parameters, and whatever I put here is going to be the scope. Okay, so what did we do? Okay, about returning. Okay, so methods, they not only can be just a sequence of operations, but they can also return something. So for instance, you may want to create a method to add some numbers, or to subtract, or to multiply. These methods, they're going to return a value, and that can be stored in a variable. Okay, we can do a little test with this later. Okay, but if you don't want to return anything, if you just want to execute a few operations, then void is more than enough for you. We also have these parentheses here. So this can be used for declaring different parameters that can be passed to the method. Okay, so for instance, if we made a method to change the channel, we would have one parameter here, which is going to be a number that says the channel we want to move to. Okay, and finally we have these curly braces again. Okay, so we have curly braces for the class definition, and we have curly braces for the method definition. Okay, so basically whatever we put here is going to be executed once the start method is called. Okay, and for instance, let's say we want to print a message to our console. So we're going to use the most basic message in any programming language you can imagine. We're going to type here debug.log. We're going to open and close parentheses and then a semicolon to finish this statement, and between the parentheses we're going to add a string that is going to be hello world. Okay, so what did we do here? Debug is a class, okay, that it's defined in the Unity engine. Okay, and that's one of the reasons we have this include here, this using instruction here. When we use the dot operator, it means we're going to access something that is inside this debug class. Okay, and we are calling a log method. Okay, so this is how we call a method. Okay, we get its name, we go to whatever it is, in this case it's in the debug class, we type the name of the method, then we open and close parentheses, and if there are any parameters that we have to pass, they're going to be here. And in this case we can just pass a string. Once we do this, we want to save the script. We go back to Unity and we're going to wait for the compilation to complete. And once it is done, and then you might ask yourself, okay, how do I call that start method? Okay, I understand that there's a log method that I can call by just typing in here, but where do things start? Okay, how do I call this method? And if you press the play button and you look at the console, you're going to see that you have the hello world message printed here. Okay, so the answer to the riddle is that the start method is the actual starting point. Okay, Okay, so if you want to initialize anything, if you want to perform any operations at the beginning of the life cycle of a component, you can just use this start method, because Unity is going to internally call this. Okay, and well, that's pretty much the reason we use this start method here. It's used for initialization of things. Okay, now this is called only once. Okay, when we press the play button, we have this hello world printed here, because it means this component is ready to be used. Okay, so the cube game object loaded, everything required to make this cube has been loaded, and now, well, we can start working with this cube script. Okay, and the other method, okay, so let's change this hello world to started. Okay, and the other method is the update method. So you can type here void update, open and close parentheses, and then open and close curly braces. Okay, so this is called once per frame. Okay, so what does this mean? When our game is running, and pretty much when any app is running, the smartphone where it is running, or the computer, is updating this app all the time. It's processing, it's doing millions and thousands of operations all the time. It's doing calculations, it's drawing pixels in the screen, it's sending messages over the internet. Things are happening all the time. And the update method is a thing that can help us a lot on making games, so we can update things pretty much live. So for example, if our game is very well developed, very well optimized, and it's running at 60 frames per second, it means that the update method is going to be called 60 times each second. Okay, so this is good for making things like checking for collisions and making movement, checking for input. So different than the start method, if we come here and type debug.log, and we open and close parentheses to add the parameters here, and we add updating, okay, and remember to add a semicolon in the end. If we save this and go to Unity, after the compilation is completed, we're going to press the play button. Okay, pay close attention to the console. We press the play button, we have the start string that appeared here, and we have lots of updating messages appearing all the time. Okay, so it's printing all the time. Another way to have a better look at this is to just select this collapse property here, and you're going to see that, well, the messages that are identical, they are being grouped together. So so far in just a few seconds we've printed updating more than 800 times, almost 1,000 times in here. Okay, so it's something that is going to help us on to achieving different things. Okay, so now that we have these methods, we have start and we have update. Let's start by using this start method. We want to put these variables to use. We want to use size modifier, and we want to use new name. Okay, so how do we change the size of the cube? We want to access a variable, and better yet, it's a property of the cube. Okay, so this is what we're going to do. In the start method, we're going to type transform.local scale. We're going to type an asterisk for the multiply sign and an equal sign, and then we're going to type size modifier and a semicolon. So what's happening here? When we type transform, it means that we are accessing the transform component of our cube game object. Okay, so we are here in the cube script, and we're going to the transform component. Okay, and when we type dot, remember, just like we saw before, the dot here that we use for debug log, for example, is basically going to make us access something that belongs to the transform component. In this case, it is the local scale property. Okay, which is going to store, well, the scale of this cube, which right now is 1, 1, 1. So it's 1 in the horizontal, the vertical, and the depth axis, in all of these 3 dimensions. And when we type multiply equals, it means that we're going to get whatever is stored here, and we're going to make it 2.5 times bigger. Okay, that's why we use this size modifier here. So if you save the script, go to Unity and wait for this compilation to complete, we can just press the play button, and notice that the cube is now much bigger than it was before. Okay, and if you want to change that size anytime, you can just come here in the size modifier and for example use 0.1, so it's going to be 10% of whatever it was before. This time, if we press play, the cube is going to be very, very little. Okay, but imagine you want to change this size while the game is running. Okay, notice that if I change size modifier to 5, for example, nothing happens in this cube. Okay, so this is where the update method might come into play. Okay, we're going to cut this line that we added here in the start method. We're going to put here in the update method, and we're going to change a few things. So we have transform.localScale. Instead of multiplying, we're going to say that it's equal to vector3.1 multiplied by size modifier. So this time we're hard setting it to be the original vector, okay, so 1, 1, 1, multiplied by whatever we have here. So if we save this, go to Unity and wait for this compilation to complete, we can press the play button, and we have our cube set at 0.1. But if you click on this size modifier label and move to the right, notice that we're changing the size of the cube at runtime. Okay, the game is playing. If the editor is a bit darker and these buttons are blue, it means that the game is live right now. So you can change the size modifier to whatever we want, and you can see here that the scale is following correctly whatever number we have here in size modifier. Okay, so we can stop this and set as 2.5, which was the beginning one. And now, if we want to change the name of the cube, what do we need to do? Okay, it's going to be very similar. Right now we press play, but the cube is still named cube. But if we go to the start method, we can type transform.name equals to new name. Okay, that's pretty simple. It's the easiest of them. If we save this and wait for this compilation to be finished, we can once again press the play button and notice that cube has been renamed to QB42. Okay, so we have the string being applied. We can change the size in here. Alright, and remember I told you we can define a different method. Okay, we can start and update our things called by Unity, but what if we want to define a method of our own? So let's say we want to improve the name. We want to add a little to add some characters to our name. We can come here and type string, and then we can give our method whatever name we want. Okay, so it's not a very good practice to just type whatever name you want here. Okay, it's just to show you that you have the freedom to do whatever you want. But let's say we want to improve our name. Okay, so let's make a method that is called improve name. We open and close parentheses, and here we're going to add our parameter, which is going to be string original string, and then we open and close curly braces. So we declare a method that is called improve name. We say that it's going to return a string. Okay, it was void in the other ones because they were returning anything, but this time it's going to return a string, and the parameter is going to be only one. This parameter is an original string. This is the name that we use for it, that I decided it's going to be original string, and the type of that parameter is string. Okay, and notice that if you save the script and you go to Unity and wait for the compilation, the console is going to show you an error. So this is our first error. So basically it's saying here, hey, the file cube.cs located in the assets folder in the line 20 in the row 16 contains an error. Okay, so cube.improveName, not all code paths return a value. So we need to return a value, okay, in here. So to return something, we can just type return and then do the thing that we want to return. If we use return 10, for example, a number, and we save this and go back to Unity, notice that we have an error. So in line 21, we can't convert int to string. This is very common when we are beginning, because the thing is, the type of the thing that needs to return here is of type string, but we're trying to return a number. But what we need to return here is another string. So this time, let's swap this to something like, let's add a double quote, then a dash, and we're going to open a bracket. Okay, and what I want to do is I want to append to this string. So I'm going to add a plus sign and put original string. Then we're going to add another plus sign. We type a double quote to make another string. I'm going to close a bracket, add a dash, and another double quote. Okay, so essentially what we're doing here is just a little styling to this string. Okay, I'm just getting the original one, adding some text before it, another text after it, and I'm going to return whatever I put here. And in the start method, I want to call this improve name method. So I'm just going to type here improve name, and I'm going to put new name as a parameter. Okay, now we save this, we go to Unity. Now we're going to wait for this compilation to complete, and after it is done and I press the play button, notice that the name of the cube is now QB42 with this little stylization that we added here. Okay, so it's a pretty simple example. We already made our own method, okay, that returns something. We changed the name of our game object, and we can even change the size at runtime for this cube. Okay, so we've learned some things in here. However, one thing that is still missing is we need to use this isRotated variable. Okay, so to learn how to do this, we need to understand how ifs work. Okay, we're going to understand how conditions they work in code. So let's do this in the next video.